All right. So, what does the word momentum mean? Sports analogy. When a team's got momentum, what does it mean? They got the power. They're like not easily stopped, right? They got energy. Does that sort of relate to the physics definition of momentum? What do you think? Yeah. What kind of things have momentum? Falling things, moving things. Does the speed that they're moving matter when it comes to momentum? Yep. What about the size of the object? Like what kind of large objects that maybe move slow have a lot of momentum and are hard to stop? Okay. Lucas, he's hard to stop, yes. Yeah. What about like trains? When a train comes into town, right, it has to slow down for safety reasons, but if you were standing on the train track and the train had to stop, would it be able to stop in time? Not likely. Why? Not because it's moving fast, because it's got a lot of momentum, a lot of mass, right? Same thing with the Titanic. Did they see the iceberg? They sure did. Was it like from me to the back of the room kind of distance? No, it was like a couple of miles. But the Titanic was exactly, hence the name. It was giant. It had a lot of mass, right? And I'll relate that to the fat equals MAV equation. It required a huge amount of force. Big objects have a lot of momentum. They're hard to stop. So there's a definition of momentum. It's inertia in motion. Yeah, I don't know what that is. So momentum, a good way to describe it is inertia in motion. Something has to be moving for it to have momentum. When Lucas is at rest, sitting there in the chair, does he have momentum? No, he has to be moving. That's why the coach calls a timeout when one team has momentum, because they want to stop the game so there's no motion going on, right? Think of it that way. Okay, so 7.1, momentum. We know that it's harder to stop a large truck than a small car when we're both moving at the same speed. We say the truck has more momentum than the car. By momentum, we mean inertia in motion, or more specifically, the mass of an object multiplied by its velocity. Momentum equals mass times velocity. You can highlight that. That is exactly what it is. Okay, momentum, we use the letter P for momentum. How come not M? Because it's mass. So they pick the next letter. That's N. Well, that's newtons. The next letter, that kind of looks like a 0. Let's go with the next one. P isn't used for anything. Is that how they did it, do you think? I have no idea. I think it's actually a Latin, it's some word in Latin, I think, is why it's P. So P is simply mass times velocity. That is it for the formula. Like simple, it's almost weird going back to simple ones like that, right? Momentum is mass times velocity. Okay, so momentum is mass times velocity. Or in abbreviated notation, momentum equals mv, or momentum is mass times speed if we don't care about the direction, which we still abbreviate mv. We can see from the definition that a moving object can have a large momentum if it has a large mass, a high speed, or both. A moving truck has more momentum than a car moving at the same speed because the truck has more mass. But a fast car can have more momentum than a slow truck. A truck at rest has no momentum at all. So even though the mass might be large, 1,000, if the velocity is 0, the momentum is 0. It must be moving, hence the term inertia in motion. Okay, and in really the tiniest font ever, I need my reading glasses to read it there. A truck rolling down a hill has more momentum than a roller skate with the same speed because the truck has more mass. But if the truck is at rest and the roller skate moves, the roller skate has more momentum because it only has speed. So, that was the answer to the question on the left there. Can you think of a case where the roller skate and the truck shown in figure 7.1 would have the same momentum? Well, if they were both at rest, right? They would have the same momentum. Okay, so that is really all you need to be able to do today. Now, what are the units? Well, if we've got P equals mv, what's the unit for mass? Kilogram, what's the unit for velocity? Meters per second. And so, the unit for momentum is kilogram meters per second. You would think they would have figured out some smart person to attach their name to that. Apparently they haven't. Want to use that? Some people get it. No, yeah. Oh, this, Nate? That? Yeah, that looks good. You like that? Capital Y or small y? Okay. Actually, you can't use B because that's magnetic field strength. Magnetic field strength is B. Yeah, well, yeah, X and Y coordinates, I don't know. So we will use kilogram meters per second squared. Unfortunately, that's the only thing we can do. Okay. Now, there is some stuff in the textbook on page 277. I realize that you probably, long time ago, stopped bringing textbooks to class, right? Yeah, in fact, I don't even know why I bother sending them out anymore. I really don't.
Well, we used them at the beginning here, then you stopped.
Yeah, I know. I wouldn't. You stop bringing them. Yeah. In fact, if you want to return it, you can. It'll always be there in the library. So momentum, it's on page 277 if you want. Momentum is defined as an object mass times velocity. Now you should also note that since velocity is a vector, that makes momentum a vector too. Which means conservation of momentum, which you probably have heard a little bit about, is vector, which means in 2 dimensions, we're going to have all that vector stuff. Hooray. Okay? No, they're not too bad. Now that I've taught you components, right, they're not too bad at all. Okay, so here's an example. It's actually from the textbook. That picture is actually in the textbook. If you want to find it, you can. Okay, I'll just do a little simple one here. Calculate the momentum of a 1 kilogram duck moving at 28 meters per second and of a sumo wrestler with a mass of 200 kilograms moving at half a kilometer an hour as shown. So I'll just do these quick here for you. If you want to jot the question down, you can. It's pretty easy. Right? The momentum is mass times velocity if we're doing the duck. Mass of the duck, it's a pretty big duck. It's 1 kilogram, 2.2 pounds. He's moving at 28 meters per second. So he has a momentum of 28 kilogram meters per second. Right? No real concept of what that means, kind of thing, right? It's almost like a made-up thing. Well, I mean, you have to be able to calculate it, but I'm just saying that it's hard to visualize. Like, it's not something you can sort of like, what's a kilogram meter per second? Like, it's hard to sort of get your brain around what that means. Okay, if we do the sumo wrestler, P equals MV. He weighs 200. He's going at half a kilometer an hour. Okay, so we got to take that 0.5 kilometers. We're going to have to divide by 3.6. Somebody do that for me. Half divide by 3.6. I have no idea. Can't do that in my head. 0.138. Okay, now take that times by 200, Cole. It should be. The point is that it's almost the same. Okay? The reason that they do that is to show you that objects can have the same momentum, right? Really big ones, like a 450-pound sumo wrestler, if he's moving slow enough, can have the same amount of momentum as the duck. If the sumo and the duck run into each other head on, what's going to happen?
Duck's going to win.
By about 0.3 kilogram meters per second, you're right. Hard to believe, right? But if the duck's moving fast enough, the duck's going to win. So it's not just mass that matters.
Wait, is that like a race?
No, if they were like running into each other, like head-to-head kind of thing, right? Yeah, well, by a little bit, right? By a little bit, right? When Lucas runs into a smaller player, Lucas is going to win if they're going the same speed. Yes, momentum. Now, there are some questions here. If you want to do them in the book, you can. They're really, really straightforward. There's like, it's mass times velocity. There's nothing to it. Okay. Again, normally I would have gone through the test, and so I've got to kind of, because I got people that haven't written it yet. Hey? Yeah, we're going to watch the cool car crash video. Do you want to start your test? Okay. Can I take you next door?